Hi, my name is Alan, and I'm back for another calculus problem. And in this specific problem, they're asking us to find all the critical points of f of x equals sine x to the fourth power. Find the critical points and then sketch the graph. So what I did here is they gave us a restriction, so we should our domain should always be between 0 and pi, right? So to find the first step I did here is find the domain. They already gave us the domain, so I wrote it down right here. That's the domain. And then the second step is to find the actual intercepts of the function sine raised to the fourth power of x, right? So we have to set that equal to 0. When we set it equal to 0, we get sine of x is equal to 0, and then x is equal to sine inverse of 0, and then x is equal to 0 or pi. Because at 0, as sine is 0 at 0, and it's also 0 at pi on the circle. So if you want to draw the unit circle, it looks something like this. Alright? So this is the unit circle. So you have right here is 0, 1. Right? Where x is 0, is 1, 0. Here x is 1 and y is 0. So cosine is going to be 1 and sine is going to be 0 here. So x is equal to 0. And then right here is -1 to 0. Same thing. X or cosine is going to be -1 and y is going to be 0. So that means sine is equal to 0 also. Right? Then you have pi over 2 up here. You have 3 pi over 2 here. You have pi here. Right? And then you have 2 pi here. Okay? Now, see, we found our first intercepts. Right? Now, the third step that we do is we find the derivative of f of x so that we can find where the function increases and where the function decreases. And it's also going to help us find where our absolute maximum, local maximum, and local mean and absolute min. So what we have here is f prime of x is going to be equal to 4 sine cube of x cosine x. Cosine x. So we set that equal to 0. So you use the chain rule right here, right? So I'm going to do that on the side. So when you have sine to the fourth x, right? So f of x is equal to that, right? So f prime of x is going to be equal to, this is also equal to sine x raised to the fourth power, right? So since that equal to that, so the derivative is going to be equal to, 4 sine of x to the third power times whatever is in here, and the derivative of sine of x is cosine of x, right? So our final answer is going to be equal to 4 sine cube x cosine of x, right? And that's what we got. That's what we did right here, right? Now to find the critical points for this and find where the function is increasing or decreasing, we set the derivative equal to 0. The first derivative equal to 0, right? To find the rest of the points. Okay. So we get x. We get x is equal to we get x is equal to 0 pi again, which we had down there, and then we get x is equal to pi over 2. Well, cosine inverse of 0, so cosine is 0 at pi over 2 and 3 pi over 2, but since they restricted our domain to 0 to pi over 2, we're just going to worry about pi over 2, right? And then you draw the number line here, right? When you plug in numbers that are less than 0, you get negative. When you plug them in this function, you get negative. When you plug in any number that's between 0 and pi over 2, you get positive. And when you plug in any number that's between pi over 2 and pi, you get negative, right? So that means that your function is increasing from 0 to pi over 2, and it's decreasing from pi to 2 to pi, right? So that means our local minimum is going to be 0 to 0, right? And pi, comma 0, and then the absolute max is going to be pi over 2, comma 1, because you plug pi over 2 in the original function, which is right here, right? Now, our fourth step right here is going to finding out where the function is concave up and concave down. So the function is concave down when the second derivative is equal to 0, right? The second derivative is equal to 0, okay? So you do the math here, right? You find the second derivative, which is going to be equal to 4 sine cubed of x, negative sine of x cosine x times 12 sine squared of x cosine x. That simplifies to that, right? And then when you simplify it again, you end up with 4 sine squared of x times 3 minus 4 sine squared of x. So 4 sine squared of x is going to equal to 0, so x is equal to 0, pi over 2 to 0. And then here you have sine inverse of square root of 3 over 2. Sine inverse is square root of 3 over 2 of pi over 3 and 2 pi over 3, since we're restricting our domain from 0 to pi, right? And then when you come on the number line here, the function is going to be concave. It's going to be concave up from 0 to pi over 3 here, because if you plug in a number between here, you get a positive number, and that's going to be concave down from pi over 3 to pi, because when you plug in any number in this function, you end up with that. Now, this pi over 3 here is going to be on our inflection point, right? And don't forget